Today you're going to be taking a set of notes on section 5.1. This is going to be a very pivotal section towards everything we do over the next few months, so slope is a very important topic. Please take a minute and write down the information on here regarding the notes and assignment numbers. Please make sure that you pause and record all this before you start taking your notes. You can find these notes in Canvas in order to print out the papers or just to view them, or you can just write this on your own sheet of paper completely. Okay, let's go ahead and get started. So first we need to define what slope is. Everybody deals with slope in their life, from roofers who are dealing with the slope of a roof, people who design roller coasters have to deal with the steepness and the slope of their hills that are in there. They have to deal with it when you're building roads, because guys, a road can't be flat. If it was, then the water would sit on it. So slope is a very important thing, whether it's a subtle slope or whether it's a very steep slope. You're going to be dealing with this all the time in real life. So they define slope as the steepness of a line. It also has another name that I want you to make sure you put right here, because a lot of people learn slope and then when they use this word or this wording on the EOC, people do not know what they're asking. Slope is also called rate of change. Rate of change. So please make sure you write that down. Understand, if they ask for the rate of change on a problem, that all they're asking for is the slope. Now there are going to be three separate formulas to be able to find the slope. The first one is going to be from a table, the second from a graph, and then from a set of points. So let's talk about each one of those formulas. First, from a table. When you're dealing with a table, the formula is going to be called the change in y over the change in x. And guys, you need to know that what they're talking about is, when you look at a table, on this table you're going to have two sides. This is going to be the x's over here, this is going to be the y's over here. So we're talking about how much does it change as it goes from each one of our y's, and then how much does it change as it goes through each one of our x's as we go through that process. From a graph, you're going to be dealing with a formula that says rise, R-I-S-E, over run, rise over run. Okay. You need to always start at the bottom point when you're doing this. It will make your life easier. If you start at the bottom point, it will make it much easier to go through the process of finding rise over run, going up first and then going to the left or right. If you do that, then it's very easy to tell whether your slope should be positive or negative. If you go to the left when you run, then it is going to be negative. If you go to the right when you run, then your slope is going to be positive. If I could spell first, positive. There we go. So when you have a problem that deals with a graph, you're going to be dealing with taking 2 points on that graph and going from one to the other. Going from the bottom point, you would rise up, and then you would run over. Okay? If you run to the right, it's positive. You run to the left, then it's negative. Okay, the last set is going to be from 2 points. The last formula is going to be from 2 points. So if you have 2 points, and remember, points are just ordered pairs. That's something you've done before. They look like this. And if you have 2 of them, they might look just the same. The only difference might be what they call these little sub-numbers. This is going to have a little 1 in the bottom right-hand corner. They are not at the top, they are at the bottom. They do not mean powers. They're to indicate they're the x from the first order pair and the y from the first order pair. And then on this one, it would have a little sub 2 down here at the bottom, meaning this is the x from the second order pair and the y from the second order pair. In order to find the slope, you're going to subtract the x's and subtract the y's. Now, just like all the others, the up and down movement, the change in y, is always going to come first. So the formula is y2 minus y1 over x2 minus x1. Guys, please listen to me. The 2's coming first doesn't matter. You can just as easily write it like this. y1 minus y2 over x1 minus x2. But you have to do the 1's first on both of them if you do it that way, or you have to do the 2's first on both of these if you do it this way. Whatever order you do it in, if you start from here and go to this one, then you have to start from here and go to this one. You just have to go in the same order. That's what matters. Okay. So let's talk about the 4 types of slope. There are 4 of them, okay? And when you do this, you read slope. This is really important. Read slope, just like you read words on a sentence. So you're going to read from left to right. Again, you are going to read your slope from left to right. So as you look at the picture, you start on the left-hand side of the picture, and you read it going across to the right. So I want you to jot down 4 lines for me real quick. They don't have to be perfect. We're just sketching these. Just something that looks approximately like these lines. Okay, first of all, let me mention something about drawing lines. If you're drawing lines on a coordinate plane, those lines need to extend past the end of your graph. They need to have arrows on the ends. Make sure you do that because that will matter a lot as we go forward. Don't put a little line that goes like this and stops right inside the graph. It needs to extend all the way through. It has to do with graphing systems of inequalities later on and systems of equations later on. So it's very important. Doesn't sound like a big deal now. It will be later. So this first type of slope, as we read it from the left to the right, goes from the bottom of the graph and goes up as it goes to the right, like you're climbing a mountain. That means that this is going to have what we call a positive slope. Right? If you start on the left side of the graph and you go down like you're sledding down a hill, that is going to be what we call a negative slope. Now, there are 2 special cases. Guys, I'm about to give some information to you that should last all 4 years of high school. It's going to be really, really important. Okay, if it goes horizontally, it is going to have what we call a 0 slope. But there's a lot that you need to know about one that goes straight across. So please listen to this little acronym and write this information down. So there is something called HOY, H-O-Y, when it comes to ones that go straight across like this. H stands for horizontal. Can't see the R and I. The line goes horizontal like the horizon going across the ocean. It is going to have a 0 slope. And the equation of the line is always going to be y equals a number. That won't make any sense yet, but it will be huge going forward. It will be y equals a number with no x in the equation when it goes this way. This little acronym is going to be crucial to you being successful throughout Chapter 5 and going forward. I cannot stress to you enough how many Algebra 2 students and Calc students still struggle with these concepts because they didn't take the time to learn this and it shows up forever. So for the next one, we have a vertical line going this way. Vertical lines have a slope that is considered to be undefined. And we'll explain why that is later on. For this moment, we're going to talk about the actual acronym and how you remember it for these kind of lines. The acronym for these kind of lines is called VUX, V-U-X. V stands for vertical. These lines are vertical lines, always going straight up and down. They are always going to have an undefined slope. Again, we'll talk about why one is 0 and one's undefined in a little bit when we do the math part of this lesson. And then it is always going to have an equation that is x equals a number, where there is no y whatsoever. Again, this acronym is always going to apply to these lines and will show up forever. So please do something to learn that acronym. Guys, it's not something you should be looking up. It's something you should know. So do something to learn that. Okay, let's go on to the next thing. So we have examples of every type of slope from a table, then from a graph, and then from 2 points. So we're going to go through and do problems for each one of these. Now, one of the things about slope is that it's called a constant rate of change. You will see a few problems that ask you if the rate of change is constant, meaning is it a consistent change as you go through. They're asking you, is the slope, remember, rate of change is just another word for slope, is it constant? Meaning, does it go through and go at a constant change? If it is, then they want you to give the actual slope. So, let's go through and walk through this process. First, we're going to say if it's consistent or not consistent. Then we're going to give the slope only if it is consistent. Excuse me, constant, I apologize. Let's try that again. I misspoke. Again, first thing we're going to do is go through and decide if it is constant or not constant. Then we're going to go through, and if it is constant, we are going to give the actual slope. So, here we go. The process is to go through and find what we call the change in y and the change in x. Remember, when you're dealing with a table, you have that formula. It says the change in y over the change in x. So, we need to find the change from here to here. Well, to go from 6 to 12, you're adding 6. Then from 12 to 18, you're adding 6. And from 18 to 24, you're adding 6. So that's the same the whole way through. Then we do the same thing on the other side. 1 to 2, you're adding 1. From 2 to 3, you're adding 1. And from 3 to 4, you're adding 1. That means it's constant on both sides, so my first answer is that it is constant. And then it actually wants the slope. So we've already done the work, we've already put it on here that it's constant. All we need to do is put the change in y, the y's are over here, guys. So it's going to be 6 over the change in x, which is right here, which is 1. And then every single slope you do, you will need to reduce it. So 6 over 1 would reduce down to 6. Okay. Now we'll do the same thing on the next one. Change in y first, because it's going to go on the top. From 5 to 1, we are subtracting 4. From 1 to negative 4, we're subtracting 5. And from negative 4 to negative 6, we would subtract 6. On this side, if we go through each one of these for our x, from negative 8 to negative 2, we are adding 8. From negative 2 to 6, we are adding 8. And from 6 to 14, we are adding 8. So the x change is constant, but the y change is not. So guys, on those problems, the only thing you write is not constant. Now, they won't ask you if it's constant or not every time. They may just ask you to find the rate of change. That means they're telling you that it is constant and just find the slope. If they ask you for both, first you've got to go through and decide if it's constant and then put the slope if it is. Okay, so those are your examples for tables. Now we need to go through and deal with graphs, which are my favorite because it's something called rise over run, and people usually do very well with this. One of the first things you have to do when you're dealing with slope on a line, again, let me write down, this is that formula, rise over run, is you need to find what we call intersection points. See all these little grid lines right here? They have little intersections on them. You're looking for where this blue line crosses those intersection points. So for example, right here, at this point on the graph, there's an intersection point and the blue line crosses it. You'll see they're evenly spaced when you have a line. Here's another one, and then there's another one right here at the edge of the graph. There's another one here, and here, and here. Take a second, make sure you've got all those marked. Notice they have to be evenly spaced if you're talking about a line. They have to be. It can't be a line. It's going to be a curve or something else if they're not evenly spaced. Now, in order to find slope, you pick any two of those points and you do what's called rise over run. So we would go from the bottom point, we would go up to the line where the next point is, and we would run over. And you'll see if you rise and run again, and rise and run again, and rise and run again, it creates like a set of steps. You don't have to do all these, I'm just showing you what happens, and that it's the same every time. Well, how much is it going up? It's going up 1, 2 blocks, and it is running 1 block to the right, and remember, when we go to the right, it's going to be positive. If we go to the left, it's going to be negative. So we went up 2, that's our rise, and we ran 1, so that gives us a slope on this line of 2. So for the next one, we're going to see that we have something right here that is going to have points here, and here, and guys, they go on and on and on. There are so many points of intersection on this one. This is a horizontal line node. You don't need any points. You don't need the rise or run formula. This is just looking at the information that we wrote down. If you have a horizontal line, the slope of a horizontal line every single time will be 0. Period. There's no figuring it out. There's no nothing. If it goes straight across, the slope is 0. Now guys, I'll show you real quick mathematically why that is. If you look at it and you do rise over run, it never rises, so it never goes up, it's 0. And it runs 1 every time, but 0 over 1 would always reduce down to 0. Every single horizontal line has a slope of 0. There's no figuring it out. You should just know that. Okay, so this last one, looking at its intersection points. There's less intersection points on this one. We've got one here, and then one here, and then one here. So those 3 points we're going to use to do our slope with. But again, please listen to me. Start at the bottom point. It will make your life easier. We are going to rise and run. Okay. We are rising up 2 blocks, and we are running 3. But because we are running to the left, that is going to be a -3. So when we set up our slope, it's going to be 2 over -3, and that would be the slope of your line. Now, I want to do something real quick just to show you, and I'm going to use a different color to do it, in case you don't pick those 2 points. Let's say you pick this point and this point. It's not going to change the outcome of your slope. That would mean that you then have a rise of 4 and a run of 6, but because we went to the left, that 6 is negative. But guys, think about it. 4 over -6 still reduces down to 2 over -3. Okay. So it doesn't matter which 2 points you pick, you will always get the same slope. So the last thing we need to do is use our formula. It has to do with the subtraction between 2 points. So when we see this type of problems, find the slope from each one of these pair of points, we are going to be doing the formula that looks like this. Y2 minus y1 over x2 minus x1. But again, I have tried to explain that it does not matter which one you put first. And most people actually do better putting the ones in front. That's just the formula you will always see written down. So, when we set this up, remember, this is my x and my y for my first ordered pair. This is my x and my y from the second ordered pair. So when I do slope, I'm going to be doing y minus y. So I'm going to take my 4, my y from here, and subtract my y from here, which would be negative 1. Now this formula has minuses in it, be careful. Over 6 from my x from my first one, minus 3 from my x from my second one. Now it's just a matter of using your calculator and getting the arithmetic right so you don't make a careless error. Guys, before you do anything, a double negative is really a positive. So if it helps you, you might want to do that before you do anything else. Then from there, 4 plus 1 would be 5, and 6 minus 3 would put you at 3. For the next one, we do the same concept. Start off with our x and our y, our x and our y. We start with the y's every time, guys. So the y's would be negative 3 minus 0 over, again, if I go negative 3 minus 0, I got to go 0 minus the 6. So 0 minus 6. That's going to put us at negative 3 over negative 6. So the negatives will cancel out, and 3 over 6 will reduce down to 1 over 2. So we have 2 more examples of that. Go ahead and let's get those last 2 and see if we can get slopes for those. Now I warn you, these are going to be special cases. We'll talk about why. We're going to show you something after the fact for you to look for and notice and talk about why they end up being the answer they use. So getting started. Again, I've got to subtract my y's, so negative 3 minus 3, going from here to here. So I've got to go here to here, which means on the bottom I'd have 2 minus 2. Now guys, when I do that math, that's going to give me negative 6 over 0. Now, you should have come here with this information, but if you didn't, you need to know you cannot divide by 0. It's not possible. That's why the slope of any line that looks like this, where 0 is on the bottom, underneath, it is going to have a slope that is undefined. Alright? You can't divide by 0, guys. So put a little note right here. If 0 is underneath, then the slope is undefined. Again, underneath means it's undefined. If 0 is underneath, then the slope is going to be undefined. Right? And we'll talk about something else in just a second that'll kind of, some of y'all won't even need to do that math eventually. Okay, so from here, the next one is going to be negative 4 minus negative 4 over 1 minus negative 2. From there, you're going to add the opposite by getting rid of both of these double negatives. When you do that, that's going to come through and give you 0 on top. and 3 on the bottom. The guy 0 cut up 3 times, 0 divided by anything is going to put you at 0 for the slope of this line. Okay. So whenever you have 0 on the top, the slope will be 0. Okay. Now, we need to connect these. That was our last example, but we need to connect these to our special cases. Please watch what I'm about to do, guys. Do you see in this problem where the slope is undefined that you have an x that's a 2 and an x that's a 2? The x's are the same. Let's talk about slopes that have, lines that have undefined slopes. So we talked about the idea that we were going to have what we call Vux lines. Right? Anytime you have an undefined slope, it is always going to be x equals a number. So whenever you see the x's be the same, then you automatically know without any work that it should go straight to undefined. And say that again, if the x's are the same, it's a Vux line, which means the slope is undefined. There's no figuring it out. If you recognize, like on the next one, that the y's are the same, then we have that special case of having what we call a Foy line. And every Foy line is going to be y equals a number. So see, the y's are the same. We've got a -4 and a -4. If that's true, then you know that slope is always going to be 0 without any work, because every Foy line is y equals a number, and every Foy line has a 0 slope. So, some connections that you need to make that will make your life drastically easier as we go forward, and they'll eliminate some work. So, that's your notes for today. Please go ahead and put this in your notes section and then get started on the assignment that goes with it.